Hello, my name is Noah Gali, and this is just an overview of the main components of a standard 3-channel RC airplane. For every airplane, including full scale, there are 3 major parts. You have your engine, your power source, and then, get closer view up here, your control surfaces. So these control surfaces are what steer the airplane. I'll get into that later. So, first off, let's just go over the motor. Alright, so this motor you see here is it's a brushless motor, meaning it's also an outrunner, which means that the outside of the engine spins instead of a shaft inside that spins. It's also very efficient and it can run on high power for lots of speed. The second electronic part that is also connected directly to the motor is the speed controller. This is like a valve, say, on like a hose. It limits the amount of power that can go toward the engine, so either faster, slower, on, off, those kind of things. And then that's controlled over all of those is the receiver. So this is a 6-channel receiver, and it has wires, you can see, and they go to the receiver and also to the 2 servos. That receiver is controlled by this transmitter. This is a 7-channel transmitter made by a company called Spectrum. It has gimbals. These are what these are called. There's four ways you can move. You can go throttle, which is up and down, your rudder, which turns here, ailerons here, and your elevator. It also has a screen, so you can edit your settings, edit your flight timer, so you don't run out of fuel before you land. Important stuff like that. Okay, so I'll plug in the battery and then we can show you some more in-depth stuff. Yeah, there's a little sound that's going to play. Okay, so now it's on. The radio's on and it's all connected. Safety, even though this is on, I shouldn't have even done that, but this is essentially something that's armed. It could injure you, hurt you. I've been injured by propellers. Very dangerous. You don't want to put your hand, face, anything that near those. Okay, so like I was saying earlier, the control surface, these are what move the airplane. So let's say if I want to turn to, say, right, I move the stick to the right on the transmitter, and then you see the control surface moves. And if I want to go left, it goes the other way, back and forth. So you're flying along, you have the air from the engine moving down, and you move the surface like this. See what happens is, see the air goes, hits this, and then is deflected off from the side. So there's a low pressure on the inside, here, on the inside of the surface. What that does, it rotates the tail around. So when that rotates, that effectively steers the airplane. And that's the same also for left and right. Another control surface which moves the plane up and down is called the elevator. Yes. That's controlled by this movement of the stick, like this elevator. When you move the stick down, the airplane flies up. When you move the stick upward, the airplane flies down. Okay, so and here's the elevator. So it works on the same principle of the low pressure, high pressure type thing. So when I move the stick down, the surface moves up in the opposite direction. So right now the surface is moved up, and like while you're flying, so the air goes over the surface, pushes down in this crack, and effectively lowers the tail and raises the nose. That makes it climb, same for going down. Okay, and now for the engine. This engine is powered by a 3-cell battery. In a LiPo battery, much like this one, the battery consists of 3 cells, like I said. Each cell has a voltage of 4.2 volts. So with 3 cells, each at 4.2 volts, it ends up being around 12-ish volts, give or take. So at 12 volts, yeah, the motor's quite powerful, and I'll just do a slight run up, but you can see. So yeah, so I mean, obviously it works. The propeller is a 10-inch by 4, I think, propeller. And what that means is that it's 10 inches wide by 4, and that is called the pitch. So for every revolution that the air screw, or what they're sometimes called, turns, the propeller effectively moves 4 inches forward for every RPM. So this would be 2 inches, 4 inches, 6 inches, 8 inches, and so on. Another thing you might ask me is, well, where's the wing? I actually just took the wing off because there's no surfaces on that wing. There's no control surfaces or roll. This is a 3-channel airplane. A plane that would have ailerons, is what they're called, would be a 4-channel plane. Let's see example of that. I have the wing here. Give me a second. Okay. Sorry about that, but okay, here's the wing. It sits just like that. And there's nothing to it. There's no wires on it. There's nothing to it. It doesn't move. It just is held on and creates lift. And that brings me to my next point. Well, what is lift? If you see, the wing has a teardrop shape, being fat here and tapering down. And so the wing is obviously moving over the front of the wing. It has to go over the top and go over the bottom, and it's split by this middle piece here. The top is rounded, so it effectively has a longer length it has to go through. So the air has to move faster than the bottom, which is flat. So with doing that, causes lift and makes the wing rise. So when that's attached to the plane, the whole thing rises. Okay, that was that. So here's more of an in-depth on the servos, which is a important part of how the plane flies. So right here, this is a servo. It's a high-tech HS55. So is that one. And see, they have the wires going from the servo to the receiver, which is the receiver is powered by the battery. And then from each servo, there's a wire. That wire travels all the way back to the control surface with the push rod. And that push rod is connected to a control horn. The control horn then moves the surface like this. And now you can see the whole assembly work together. Okay. So yes, that's it. This is called a slow stick. And now for my last segment, this is about batteries and battery charging. So this is my battery charger. It is a Turnigy 4 battery charger. This charger is run on a 300-watt computer power supply. With that power supply, it takes 110 volts from the outlet and transforms that into 12 volts. So this is a 12-volt charger. So I set the charger on 3 cells, like it is. And these batteries, I don't know if you can see, but this is 22. That's for 2,200 milliamps. So if I want to charge a battery at 1C, I would charge it at 2.2 amps. If I wanted to charge a battery at 2C, I charge it at 4.4 amps. As you can see, I'm charging these batteries at 2 amps for both of them. And that is because I've used them a lot and they need to somewhat recover. So I'm going like 1.8C, just a little bit healthier, kind of lets them rest, but still puts the charge back into them. Thank you for watching, and this is how an RC airplane works. Thank you.